Hi everyone, today we will be discussing what is correlation, how it is used in analyzing the data. Correlation is a statistical tool that helps to measure and analyze the degree of relationship between two variables. So when we are concerned about the degree of the relationship of certain variables, then we are obliged to use the correlation. The measure of coefficient called the correlation coefficient. The degree of relationship is expressed by coefficient which range from correlation. R is greater than or equal to -1 but less than or equal to +1. So when the correlation is -1, that means to say that they are negatively correlated. And when the measure is +1, it means to say that they are positively correlated. The correlation analysis enables us to have an idea about the degree and direction of the relationship between two variables under study. So the correlation analysis helps us to identify what is the degree, if it is strongly correlated or negatively correlated, and its direction, if it's going up or going down. Next, there are three types of correlation. First, we have positive correlation. When we talk about positive correlation, it means to say that the values of two variables changing with the same direction. Say for example, we will consider the example for height and weight. When the height increases and the weight increases, therefore the two variables have the same direction and they are having a positive correlation. Next type of correlation is what we call negative correlation. The correlation is said to be negative correlation when the values of variables change with opposite direction. So talking about the negative correlation, when one variable increases and the other variable decreases, so that will be the time that the correlation is negative. Say for example, the quantity and the price. When there is a certain sale on a certain company, you want to buy many things, so the quantity increases, but because of the sale, the price decreases. So if it is increasing versus decreasing, therefore there is a negative correlation. The last type of correlation is what we call no relationship. No relationship at all when our correlation is equal to 0. So we can also use the scatter plot to determine the relationship between two variables, and it is the portrayal graphically on the x and y axis. So take note on this example, we have here a positive correlation. So let's see on the scatter plot what happened on the scatter plot when you observe on here the data are increasing. So if the x-axis is increasing and the y-axis is also increasing, look at here, therefore there is a positive correlation. And that is determined using a scatter plot. Here we also have the negative correlation. Take a look at here. The x-axis is decreasing, but the y-axis is increasing, or the y-axis is decreasing but the x-axis is increasing. So the reliability of a car versus the age of a car decreases. So that is why there is a negative correlation. Next to have is no correlation at all. There is no correlation between the pulse rate and the weight. Just take a look in our scatter plot. There is no decreasing and increasing order in this graph. Therefore, the type of correlation that this graph contains is no correlation at all. Types of correlations and the corresponding relationship between variables. So what happens to x variable x? What happens to variable y? Type of correlation, value, and example. So let's discuss this one by one. If the x increases in value and the y also increases in value, therefore the type of correlation is positive or direct. Its value, the correlation value, is positive and ranging from 0.00 to positive 1. Example for this is the more time you spend studying, the higher your test score will be. Next one, if our x decreases in value and our y decreases in value, again, there is a direct or positive correlation because the two change together. Its value is positive and ranging from 0.00 to positive 1. Example, the less money you put in the bank, so the x increases, the less interest you will earn. So the y also increases, therefore there is, because both are decreasing, so therefore there is a direct or positive correlation. Next one, if x increases in value and y decreases in value, there is an indirect or negative correlation. Its value is negative and is ranging from negative 1.00 to 0.00. Example, the more you exercise, the less you will weigh. The last one, if your x now decreases in value and the y increases in value, again, there is an indirect or negative type of correlation. Its value again is negative, ranging from negative 1.0 to 0.00. Example, the less time you take to complete a test, the more you'll get wrong. Okay, do you understand? Now let's move forward. So there is what we called rules of thumb. So we have here size of correlation coefficient and its general interpretation. Now, upon looking at it, when can we interpret a certain correlation? Now, if the size of correlation coefficient ranging from 0.8 to 1.0, that is very strongly correlated. If it ranges from 0.6 to 0.8, there is a strong correlation. If 0.4 to 0.6, there is a moderate correlation. If 0.2 to 0.4, there is a weak correlation. And if that is 0.0 to 0.2, very weak, or there is no relationship at all. The strength of the correlation depends on how many data points in the scatter plot are near or far in a pattern. This is similar to error in data, which comes from other explanations. So, our correlation ranges from negative 1 to positive 1. Now, when can we say that it is strongly correlated, strong correlated, moderately correlated, or no relationship at all? We will use the rules of thumb. Simple correlation coefficient. So, this is one kind of a correlation. Simple correlation coefficient. It is also called Pearson's correlation or product moment correlation coefficient. It measures the nature and strength between two variables of the quantitative type. So remember, Pearson product correlation measures the strength and the nature between two variables in a quantitative type. The next one is the Spearman rank correlation coefficient. It is non-parametric measure of correlation. So when we say non-parametric, the data are not normal. This procedure makes use of the two sets of ranks that may be assigned to the sample values of x and y. Spearman rank correlation coefficient could be computed in the following cases. Both variables are quantitative. Both variables are qualitative ordinal. One variable is quantitative and the other is qualitative ordinal. So, when these three cases are found, therefore we will have to use the Spearman rank correlation. But you must have to take note, when you use the Spearman rank correlation, make sure that the datas are non-parametric. Next, advantages. So what are the advantages of applying correlation in your studies? It shows the amount or the strength of relationship present. So when you are really concerned about the degree of the relationship between two variables, you will have to use the correlation for analyzing your data. It can be used to make predictions about the variables under study and easier to collect correlational data. Now, there are three stages in using a statistical test. First is the ad hoc. So in ad hoc, you will be assuming the level of the variables. What is the level of the variables? You will have to test its normality. You will have to test the homogeneity of variance using Leven's test, and you will have also to find out the linearity. So if all of this are correct, therefore you will be going to use the parametric test. But if one of this one is violated, then you will be going to use the non-parametric test. Then second one is to use the appropriate test. Then third one, post hook. So post hook, you will use the post hook after the test. In post hook, you will again think if the one that you are analyzing is correct. So here an example. Hypothesis. We have here a hypothesis. Is there a significant relationship between the score? So when will be we using a certain type of correlation? So here it is. If it is Pearson product correlation, if the data are scale and normal, therefore we're going to use the Pearson product correlation. And if the data is non-metric and non-normal, therefore we will use Kendall-Tau B. And if it is ordinal and non-normal, therefore we will use the Spearman rho. So I'll give you an example on how to use the SPSS when we are conducting correlation. So we have here data. There is a respondent's gender, method, pre-test, and post-test. But first one is we will look in the variable view. That is the pre-test and the post-test. Since it is our independent variable, it is a scale. So now, first to identify if our data is normal or non-normal before we proceed on what type of correlation will be used. So analyze. You can use the non-parametric test, legacy dialogues, one sample, Kolmogorov, Smirnov. You click this one. Then you have the pre-test. You put this one into test variable list and also the post-test. Then click OK. So the test distribution, you want to know if our data is normal. So upon looking on the significance level, look in the significance level of the pre-test, it is 0.330, and 0.330 is greater than 0.05, which is our level of significance. Therefore, the pre-test scores is normal. Now we'll look forward on the post-test. The level of significance for the post-test is 0.229, which is way greater than 0.05. Therefore, the data for the post-test is also normal. And since it is normal, we will now use the person-product correlation because our data are scales and normal, so we will use now Pearson product correlation. So going back here on our data view. So we want to know if there is a strong correlation between the pre-test and the post-test score. So you have here, you click analyze, then correlate, bivariate. So you have here, for our variables to be test, we have the pre-test and the post-test. Then correlation coefficient, we have Pearson. Then click OK. Click OK. So we have here, let's make it down. Oh, correlation. Wait. So here it is. I know. No. Sorry. So for the correlation, take note on the correlation, it is greater than 0.481 for the post-test. For the pre-test, there's none. So it means to say that there is no relationship between the pre-test and the post-test, since it is greater than 0.05. So I hope you understand about this topic. See you again next time for my next demonstration. God bless everyone. Bye-bye.